Hi students, today we are discussing the next in first part of behavioral design pattern part 1, the last design pattern, that is in fourth unit, the first part, that is iterator design pattern. What is the main intent? That short statement that tells you what is iterator design pattern. What is the main intent? In the sense to provide a way to access the elements. We are accessing the elements of an aggregate object sequentially without exposing its underlying representation. What here the says, they provide a way we are accessing the elements of an aggregate objects in a sequential manner, just without exposing its underlying representation. Here it plays an important role like Java connections, like array list, tree list, some collection of aggregate objects, or we can say some collection of objects, like example student object information. Mainly our introduction of iterated design pattern, it is mainly commonly used in design patterns. It is mainly commonly used a design pattern in Java connections and net programming environment Here a standard way to iterate the collection of an elements of an aggregate objects, how we are accessing the elements of a collection object in a sequential manner without need to know its underlying representation. What the main intent here? If we have to do the collection of objects in sequential manner, like the collection can be list and sets, unordered list. If you know Java collections, ordered collections like list, unordered collections like sets, like trees, arrays, and it can be anything, whatever it may be, and it can be anything. In object oriented programming subject point of view, the iterator design pattern is a design pattern in which an iterator, what this says, iterator, it iterator is used to traverse a container. Iterator is used to traverse a container. In a container, for example, if you have to take some material like medicine, food, and whatever it may be, toys and books, the container it have some materials you have to pack and reach to that some particular place, whatever it may be, Chennai or whatever it may be. The person, the iterator delegate some that particular materials, okay, like a container in which an iterator is used to traverse a container and access those container materials or elements, whatever it may be, and access the container elements. What the main intent here? To provide a way we are accessing the elements of an aggregate objects. Here we are traversing abstract. We need to hide the details of traversing the collections, whatever you doesn't know the inner matter. But for example, if we have to take example, different types of collections in an application. In an application, we are taking different types of applications such as arrays, linked list, and etc. We can just traverse and iterate those elements or objects without knowing the actual implementation. This is the main concept. Just we are taking some collection of instances of an object, and just we need to iterate that. Next, the user maintaining the delegated materials. container, how we can access those elements of an aggregate object in a sequential manner without need to know its underlying its representation. Okay, this is the main concept, this is the main intent of iterator design pattern. It is also known as, we can say, cursor. What we can say, cursor. And coming to the motivation section, what is the main motto of iterator design pattern? In the sense, if you see an aggregate object, some aggregate objects such as, already I say, unordered list, ordered list, collections, ordered collections, unordered collections like list, set, whatever it may be, an aggregate object such as a list. Likewise, it should give you a way, to provide a way how to access those elements without need know its underlying its representation, and without exposing its internal structure, how it will be. Okay, so our problem our problem, moreover, you might want to traverse the list in different ways, and depending on what you want to accomplish, but you probably don't want to bloat the list interface with the particular operations for different traversals, so even though if you could anticipate the ones just you will need, you might also need to have more than one traversal appending on the same list. Okay, just you might need to have a more than or multiple traversal pending on the same list. Here the main the iterator pattern, the solution lets you see here, the main key idea in this pattern is to take the responsibility in the sense, one of the duty for accessing and traversal out of the list objects, whatever we are accessing those elements, and put into an iterator object, Here we are studying the iterator class. The iterator, just the class, defines here an interface. The iterator class defines an interface. In the sense, intermediary acts as an interface for just we are accessing the list of elements. An iterator is an object. It is very responsible for keeping a track of the correct elements, that is know which those elements have been traversed already. For example, here we have to take some list class. In that list class you would call for a list iterator. In a list class you would call for a list iterator with the following relationship here. Some of the operations and methods we need to use here: count, append element, in the sense adding some elements, removing some elements. Here you could call for a list iterator, just you have to take some list, first function, next function, is done function, current item function, some index. In the sense here, just the correct item operations, just we need to return the correct element in the list. First you need to initialize the current element to the first element, Next you need to take that advance the correct item operation returns the correct element in the list. First initializes the correct element to the first element. Next, if we have to be advance the correct element to the next element, and is done is their function. The test whether if you have advanced beyond the last element, that is we are finished with the traversal or not. Just we are separating the traversal mechanism. from the list of objects, let us you define the iterators for different traversal policies without enumerating them in the list interface. Okay. Now we see in, for example, here some filtering list iterator. In the sense, it just might provide access. If you just provide access only to those elements, to those elements just that satisfy the specific filtering constraints, in the sense some specific filtering conditions. Just if we have to notice that the iterator here, just the iterator and the list are coupled. Whatever the client must know, that is a list that should be traversed as opposed to some other aggregate structure. So hence the client commit to a particular aggregate structure. It would be very better if we could change just the aggregate class, and without changing the client code. We can do this by generating the iterator concept. We can do this by generating the iterator concept. We need to support here polymorphic iteration. One or more forms you can form in the iteration section. As an example, let us assume that we also have here some skip list. Skip list implementation of a list. Okay, here a skip list is a probabilistic data structure. A skip list here, it is a probabilistic data structure with some characteristics. It is very similar to balanced trees. It is very similar to same to balanced trees. Just we want to be able to write the code that works for both the list purpose and skip list object purpose. Just we have to be define here an abstract list class. Listen carefully, an abstract here I am creating here. Just we need to define here an abstract list class. Here look at this diagram that provides a common interface. Listen carefully. That provides a common interface for manipulating list, for manipulating in the sense for handling the list. Similarly, in the same way, we need an abstract iterator also. Listen carefully. We need an abstract iterator class just that defines a common iteration, that defines a common iteration interface. So then we can define the concrete iterator. We can define the concrete iterator subclass. The concrete iterator subclasses for those different list implementation. Here as a result we see the iteration mechanism becomes independent of the iteration process becomes independent of concrete aggregate classes. Okay, here the diagram says how to create the iterator. The remaining problem here we are studying here. Listen carefully. The remaining problem is how to create the iterator. Since we want to write just code that is very independent of the concrete list subclasses, so we cannot simply instantiate a specific class here. Just we make the list of objects we are accessing, the elements. Just we are responsible for creating their corresponding iterator. Okay, the list of objects, just we are taking some responsible for creating their corresponding iterator. So this requires an operation like create iterator. This requires an operation like create operator. Okay, create iterator through which the client should support an iterator object. Okay, so here the create iterator is a best example of a factory method design pattern. Okay, so we use here to let a client, here look at this, the client is there, the client asks a list of objects for the appropriate, in the sense for the suitable iterator. So the factory method approach come forward, it gives rise to two class hierarchies. How many class hierarchies they give? Two class hierarchies, one for list and another for iterator, one for list and another for iterators. So here the create iterator factory method, just we need to connect the two hierarchies, okay. Coming to the applicability in the sense, what are the why we are supposed to use the iterator design pattern, when we are used to suppose that, in the sense, just we are use the iterator pattern here, just we to access an aggregate objects, content without exposing its internal representation, without exposing, or we can say without need know its underlying its internal structure or internal representation, whatever it may be, the underlying representation, to access an aggregate object content without exposing its internal representation. And coming to the second applicability, just we need to support, we need to provide the some more than one traversal of aggregate objects, in the sense, just we need to support multiple traversals of aggregate objects. And coming to the third applicability of iterator design pattern, just we need to provide a uniform interface. Just you need to provide a uniform in the sense same, so unique, to provide a uniform interface for just we are traversing those different aggregate structures, that is to support the polymorphic iteration. Okay, it comes under the category of object behavioral design pattern. Coming to the structure here, coming to the structure representation here, look at the structure here, aggregate here, just the aggregate, a client, iterator, concrete aggregate and concrete iterator. Some just we need to return some new concrete iterator of this function. Okay, this is the structure representation. What the structure says to you, how those classes and objects, how they are interrelate, how that particular scenario will be, in the sense, first of all we see iterator in the sense, here just we need to define the participant and interface for those we are accessing the elements and traversing the particular elements. Okay, just we need to define an interface for accessing and traversing those elements, that is nothing but iterator. And coming to the concrete iterator in the sense, just we need to implement the iterator interface, just we need to implement the iterator interface, just we need to keep track of the current position, just we need to keep track of the correct position in the traversal of the aggregate object, And what is the meaning of the aggregate section? Coming to the aggregate, just we need to define an interface, for creating an iterator object, here let us see, create iterator for creating an iterator object. And coming to the concrete aggregate in the sense, you just need to implement the iterator creation interface, just we need to return an instance of the proper concrete iterator, just we need to return an instance of the proper concrete iterator, this function. Okay, coming to the collaboration section, the collaboration, how those classes and objects, those collaborate and participate to carry out their particular responsibilities here, in the sense, a concrete iterator, just we need to keep track of the current objects, whatever we are those accessing, to provide a way we are accessing those objects or elements of an aggregate object. We are just the concrete iterator keeps track of the current object. keeps track of the correct object in the aggregate interface, how we are creating an interface object, and can compute, in the sense, and can calculate and can compute whatever the succeeding object in the traversal, Okay, let us see the consequences part. In the consequences, there are three important key essential consequences. The iterator pattern has three important consequences. The first one is nothing but it supports variations in the traversal of an aggregate. In the sense, just we need to study here the complex aggregation, we need to study about here the complex aggregates. Just it may be traversed in many ways, For example, if we have to generate a code generation and semantic checking, in the sense syntax and semantic checking, it involves traversing parse trees. So here the code generation may traverse the parse tree in order or pre-order. And coming to the iterator design pattern, it make it very easy to change the traversal algorithm. Just we need to replace the iterator instance with a different one. Just we need to replace the iterator instance. Here you can also define the iterator subclasses. We need to support the new traversals. And coming to the second consequences, iterator just simplify the aggregate interface. How we have to be just simplify the aggregate interface? Iterators traversal interface, just they need the similar interface in aggregate objects, thereby just it simplifying the aggregates interface, And coming to the third consequence here, more than one, in the sense multiple traversal can be pending on an aggregate object. Coming to the iterator design pattern, it keeps track of its own traversal state. Therefore you can have more than one traversal, in the sense multiple traversal is progress at once. Here simply what I am saying, more than one traversal can be pending on an aggregate object. How? In the sense, an iterator just keep track of its own traversal states. So therefore you can have more than one traversal. We need to progress at once. Okay, in further video we see in implementation section noun uses and what are the related patterns of iterator design pattern. Up to now, thank you one and all.